My name is Jung Hui Mei. My matric number is 298541. Now I'm going to present the question 1. First, what is the difference between a null hypothesis and the alternative hypothesis? The null hypothesis is a statement of no effect or no difference between variables. It represents the default position or assumption that no relationship or significant impact on the population exists. And for the alternative hypothesis is the opposite of the null hypothesis. Instead, a relationship of a or a significant effect between the variable in the population. The null hypothesis is denoted as H0 in a statistical notation, and the alternative hypothesis is noted as the HA or sometimes H1 in statistical notation. When testing, the null hypothesis is initially assumed to be true, and the alternative hypothesis is what researchers are typically interested in demonstrating. In the part of conclusion, the null hypothesis if the statistical analysis does not provide enough evidence to reject the null hypothesis, it is typically retained. For the alternative hypothesis, if the statistical analysis provides enough evidence to reject the null hypothesis, the alternative hypothesis is accepted as the more possible explanation. Next, what is the difference between a one-tail test and two-tail test? For the one-tail test, is a theoretical hypothesis test in which an alternative hypothesis has only one end. But for the two-tail test, it's a significant test in which the alternative hypothesis has two ends. For the determine, the one-tail test checks the relation between the variable in a single direction, but the two-tail test checks the relation between the variables in any direction. In the testing of the one-tailed test, the critical region lies entirely on either the right side or the left side of the sampling distribution. By the two-tailed test, the critical region is given by the portion of the area lying in both the tails of the probability curve of the test statistic. For the statistical power, the one-tailed test has higher statistical power compared to a two-tailed test because its critical region is concentrated in one tail, but for the two-tailed test, it has lower statistical power compared to a one-tailed test because the critical region is divided between the two tails. For question C, what is the mean by a p-value? P-value is a statistical measurement used to validate a hypothesis against observed data, measure the probability of obtaining the observed result, assuming that the null hypothesis is true. To solve the question D, step 1, the null hypothesis is population mean equal to 6.6. The alternative hypothesis is the population mean is not equal to 6.6. Step 2, the level of significance is equal to 0.05. Step 3, we will use the t-distribution since the sigma is unknown. Step 4, we will reject the H0 if computed critical T is more than 2.447 or if computed critical T is less than negative 2.447. Step 5, to test the T statistic, we calculate the sample mean is equal to 7.557 and its standard deviation is equal to 1.177 and the sample size is equal to 7. So we computed the T is equal to 2.151. So our decision is 2.151 is fall outside the rejection region. H0 is not rejected. We conclude that there is not a statistical significant change in the average weight of the newborn infant at the Jitra Hospital.
Good afternoon, doctor. My name is Jojunta. My channel number is 845. Now I'll continue to present question 2. This is the 5 step of perform hypothesis testing. Step 1, state the null hypothesis and the alternative hypothesis. Step 2, select the level of significance. Step 3, select the test statistic. Step 4, formulate the decision rules. Step 5, make a decision and interpret the result. We must determine that the H0 is mu less or equal 90, H1 is mu more than 90. Step 2, the significance level is 0.1. Step 3, we use the t-division since standard deviation is unknown. Step 4, reject H0 if computed t more than 1.29. Step 5, simple mean is 94, population mean is 90, sample size is 100. We use the formulas of T statistic, get the answer is 1.82. For the decision, 1.82 falls inside the rejection region. HO is rejected. We conclude that there has been an increase in selling time. For this question, HO is mu1 less or equal mu2. H1 is mu1 more than mu2. Less mu1 is fast food worker and mu2 is restaurant worker. Step 2, the significance level is 0.1. Step 3, we use T distribution since standard deviation is unknown. Step 4, reject HO if computed T more than 1.363. For fast food worker, simple size is 6, mean is 142.5, standard deviation is 12.243, and for the restaurant worker, simple size is 7, mean is 130.286, standard deviation is 15.787. We use the formula of operation standard deviation. Get the answer is 2004.076, and we use the formula of T statistic. Get the answer is 1.54. For the decision, 1.544 inside rejection region. HO is rejected. We conclude that the mean salary is greater for the fast food worker than the restaurant worker. P-value is between 0.05 to 0.1. This for my part. Thank you.
Question 3A. An investigation of the effectiveness of the training program to improve customer relationship include a pre-training and post-training customer survey to compare the difference they compute post-training survey score with pre-training survey score. 7 customers were randomly selected and complete both surveys. The result we can see from below table. For a 0.05 significant level, what is the decision regarding the hypothesis that the training was effectively in improving customer relationship? We have 5 steps to perform the hypothesis testing. For step 1, from the question, the training was effectively in improving customer relationship. So, H0 is mean D less than equal to 0. H1 is mean D more than 0. And steps 2, the level of significance is 0.05, which also can get from the question. And step 3, use the T distribution, because the standard deviation is unknown. Step 4, reject HO if compute T more than 1.943, which we can get from the T table. And step 5, the mean of the difference we can find, use calculator, which is 2. And the standard deviation of the difference is 2.0x2, and the number of difference is 7. To find the compute T, we use the formula, the mean of the difference divided by the standard deviation of the difference divide square root of number of difference, which is 2 divide 2.0x2 divide square root 7, which equal to 2.54. The decision is 2.54 fall inside the rejection region. HO is rejected. We conclude that the training was effectively in improving customer relationship. For the B, the following is a partial ANOVA table. Complete the table and answer the following question. Use the 0.05 significant level. A. How many treatments are there? From the above table, we can find the SSE, which is MSE times n minus k, 20 times 11 minus 2, equal to 180. To find the SSD, we use the FS total minus SSE, 500 minus 180 equal to 320. For B, what is the total sample size? Total sample size is equal to the DF total plus 1, which is 11 plus 1 equal to 12. C, what is the critical value of F, which we can get from the F distribution table? The numerator is k minus 1, which is 2, and the denominator is n minus k, which is 9. So the critical value is 4.26. D. Write out the null and alternate hypothesis. HO is mean 1 equal mean 2 equal mean 3, and H1 is the mean are not all equal. And E. What is your conclusion regarding the null hypothesis? We need to find the compute F first, which is MST over MSE. MST is SSD over N minus K, which is 220 over 2 over MSE, we get is 20, equal to 160 over 20 is X. For the compute F is X, critical F is 2.46, so F is larger than critical F. The conclusion is reject the null hypothesis because the compute F value is larger than the critical value. And the question C, Jacob Lee is a frequent traveler between Los Angeles and San Diego. For the past month, he wrote down the flight times in minutes on 3 different airlines. The result have given at below table. Use the 0.05 significant level and the 6-step hypothesis testing process to check if there is a difference in the mean flight times among the 3 airlines. Step 1. We can see from the question, there's a difference in the mean flight times among the 3 airlines. So, HO is mean G equal mean J equal mean C, and H1 is the mean are not all equal. For step 2, the level of significance is 0.05, which we can also get from the question. Step 3, use the F statistic because we are comparing means of more than 2 groups. And step 4, reject HO if compute F more than 3.295. Step 5, we need to prepare the table. First, we need to find the total sum of square. We can find the grand mean first, which is 52.17. Then use the number minus grand mean 1 by 1. So we can get SS total, which is 796.97. DF is total number is 35 minus 1, which is 34. Now we can find sum of square of error. We need to find out the mean of these 3 groups first, which is 50.5 for Ghost, 52.07 for Jackrabbit, and 55.71 for Clapton. After that, also use the number minus the mean. For Ghost, 51 minus 50.5 until the end, and for the Jackrabbit, 50 minus 52.07 until the end, and the last is the Clapton, 52 minus 55.71 until the end, which we will get 669.86. The F for arrow is N minus K. N is 34, K is 2. 34 minus 2 is 32. We can get the sum of square of treatment, which is SS total minus SSE. 796.97 minus 669.86 equal to 127.11. And DF is 34 minus 32 is equal to 2. After that, the mean square is sum of square of treatment divided by DF of treatment, which is 127.11 divided by 2, we'll get 63.555. Mean square of error is 669.86 divided by 32 equal to 20.933. So we can get the compute F by MST 63.555 divided by MSE 20.933 equal to 3.036. For the conclusion, do not reject the null hypothesis because the compute F value 3.036 less than the critical value 3.295. We conclude that there is no difference in the mean flight times among the 3 airlines.